thanks for coming. Yeah, my name is Kevin, and over there sits my colleague Christopher, and together with our both students, Timo and Lucas, we are currently developing on GRADOOP. And short disclaimer, but wanted to do that. Currently we are hiring. We have a lot of open positions and projects in various topics. So if you're interested, please visit our page, and of course send an application if you want. Okay. I guess motivation, I can do it fairly shortly since we are here in the graph dev room. You all know what graphs are. You know that they can be directed, they can be labeled, and they can have some certain properties, nodes and edges. Yes, so this is basically known as the property graph model, right? So let's take a look at GRADOOP. So GRADOOP is an open source framework which can handle heterogeneous and now temporal graph data in kind of a distributed manner. If we take a look at the GRADOOP stack, we will see that we are embedded in the Hadoop ecosystem, and with that we can use graph storages like Apache Cumulo and Apache HBase as data sources, and on top of that we are building on Apache Flink. For those of you who doesn't know about Apache Flink, Apache Flink is basically a distributed data flow engine which offers certain data structures and certain data flow operators which we use to implement our model and our graph operators. So currently we are on Java 8 and we are using Apache license 2.0, and we are releasing weekly snapshots, and we are deploying our stuff to Maven Central. So if you want to get in touch, you just can use our Maven dependencies. Okay, if you use GRADOOP, you will notice some unique features, which are basically extensions of the common property graph model. First of it would be the concept of logical graphs. A logical graph is basically an abstraction of a subgraph, which gives the subgraph more meaning. Like nodes and relationships, a logical graph can also process labels and properties. Behind me you can see three pathways overlapping logical graphs. GRADOOP is able to process one single logical graph or all of them in a graph collection. The second feature that comes with GRADOOP is a set of operators. Since we have those two classes, logical graphs and graph collection, we can divide our set of operators basically in two classes. One class that can consume logical graphs, 1 or 2, and one class of operators that can consume a graph collection, 1 or 2 at a time. For example, our grouping operator up there is consuming a logical graph and produces a logical graph. On the other hand, our pattern matching operator consumes a logical graph and creates a graph collection. And in addition of that, we are also able to run graph algorithms on logical graphs as well. Okay, and the third extension to the property graph model is our temporal extension. Our approach to handle over time evolving graphs is to add B-temporal attributes to all the elements of our graph model. So to nodes, to edges, and to logical graphs as well. We distinguish between two types of temporal attributes. First, validate time or valid time. And this time, well from and well to. Valid time is basically a user-defined property. You can decide what data you want to store in there. So for example, Chris over here started at the company in 2011, and his contract goes up to 2019. On the other hand, the transaction time is a system-based property. So for example, the transaction from timestamp was set as soon as the element gets created within the GRADOOP system. Those time attributes are first-class citizens in our graph model. Okay, as soon as we finished, to extend our graph model with this time attributes, we added another class of operators. We added specific operators that can handle those time attributes. We basically implemented two new types of graphs, temporal logical graph and temporal graph collection. And we made sure at the time we implemented this that all the classic operators are also able to use temporal logical graphs and temporal graph collection. So there's no trade-off in using the classic model or the new temporal property graph model. Now we implemented three operator snapshot difference and grouping. Pattern matching is still work in progress. And what you can do with those operators, my colleague Chris will tell you.
So thank you. So now I will continue with a very simple use case to show the flexibility of our operators and how we can chain them together to build a temporal analytical workflow with our GRADOOP system. So imagine we have a hospital with different services inside, so accident and emergency, to surgery, cardiology, or oncology. And imagine these the employees wearing a RFID sensor that captures the when people meet in this hospital. That means, okay, two people talking to each other or get in a smaller radius, then this RFID sensor captures that and collects data like these two employee IDs and the timestamp when this meeting happens and when it ends. So we have here a time period when this connection happened. So, and this is captured over weeks and weeks in this hospital to see, okay, how these connections evolve over time. And another fact is that we have a virus in our hospital. It's called virus X here. The symptom is that a third eye is growing on the head. So you see when someone is infected by that virus. And another property is there's transmission of that virus to another person is only given if the contact of them is over 5 minutes. So it's a quite simple constraint in our case. And the incubation period is 5 time units in our case. That means if someone is infected and we detect them, then we have to have a look at the time period, 5 periods ago, these infection, to see, okay, which contact this person had in the past, to see, okay, for example, which services of this hospital we have to put in quarantine. So, okay, so our question is, in case of an infection, so which hospital services are at risk on contracting the virus? Okay, so imagine we have this full history of our graph and connections here on the left side. We have our time scale here at the bottom. And we are just, with our API, loading our graph from a data source. It could be a CSV from HDFS or a Cumulo or HBase. And we have a lot of data integration operators to parse these contexts from the RFIDs to a logical graph, or in our case here, a temporal graph. Okay, and when we have a look at one specific edge, how it looks like, we have two employees of the service oncology. And our contact edge is attributed with these time interval that represents the time when these two people meet each other. So these are the data. On the left side, we see, okay, here 5 time units contact. I marked them here in our timeline just for example. And now the case arrives, breaking news, virus is detected on one person in the oncology. At time point T20, I marked them here in our time range. And now we want to know in the last 5 time units, because that is our incubation period, what happened inside here in our temporal graph. And therefore, to achieve this, to don't look at this whole graph, but only the part or this period of the graph, we can apply our snapshot operator. The snapshot operator is applied on this full history of this graph and consumes a temporal predicate. And we are we built some predefined temporal predicates oriented on the SQL 2011 standard, the temporal extensions of SQL, like from, to, as of, between, and so on. But you can also implement your own temporal predicate if you have any special conditions or something else. So in our case, we applied a from to operator from time point 15 to time point 20. And if we are applying that, all edges removed that are not considered to that time range here. So, and now, because this graph can be very huge, maybe we will see it here in the small example on view here, but if this graph is very huge, we need a better view on all these connections. So for that, we are applying our group by operator. The group by operator gets a specific grouping configuration. As first argument, we need a specification where the vertices, or on which criteria the vertices should be grouped. And we are selecting the service property of each vertex to gain a grouping on that all employees that working in a specific service are grouped together to a super node. As second argument, we can give aggregation functions for that vertices, so which this super vertices should be aggregated. We don't need anything for our use case here. The third argument is where we want to group the edges. We want to group the edges by label because we have only connected edges here inside. And we want to aggregate all grouped edges to calculate the maximum duration of that contact. To know, because our rivals, the transmission is only given if the contact is larger than 5 minutes. We want to know, okay, what is the maximum duration of a contact here. And if we apply that group by operator, we have now grouped all vertices with the same service together. And on each edge, we have a new property called maximum duration here that captures the maximum duration of all grouped edges inside our graph. And as you can see here now, the only durations that exceed these 5 minutes are inside here this from the oncology people, and between the oncology and surgery, and inside the surgery. Yeah? Also, this duration exceeds, but they are not connected to the other graph where the infected person is. So that means we don't have to consider this. And then we can extend this workflow, for example, by filtering now for connections over 5 minutes. And we know, okay, the employees of the oncology and surgery have to be put under quarantine to prevent the spreading of our virus. So I know this is really a very simple example, but you see you can glue our operators together to build this analytical workflow. And now we can put the result of that in we have a dot file sync where you can look at this graph with GraphViz, or put it in a CSV back to an HDFS, or back to Accumulo, back to HBase, and so on. So this is only a short example. To sum up all the things, so we have a distributed graph analysis platform called GRADOOP. In GRADOOP, we have a temporal property graph model with bitemporal support. In my example, I just talked about the valid time, but also transaction time is supported by all these operators. We have logical graphs and sets of them called graph collections. And we can compose all our operators together to build or have a flexible mechanism to build an analytical workflow. Yeah, and if you want more information, then visit our website, GRADOOP. This redirects to our GitHub repo. We have a good wiki where every operator is explained, how it works with examples and so on. We have a getting started guide where there's a short input graph and you see an example workflow, how to work with GRADOOP. And we have a lot of examples also in this temporal area. Then you see how GRADOOP works in specific. Yeah, and since every operator is built on top of or with Flink operators, everything is distributed in our environment. And the papers that are linked on the GRADOOP page have also some evaluation results that shows the speed up on bigger clusters. Yeah, and that's it. Okay, thank you.
Yeah, thanks a lot. Unfortunately, we have only time for 1 or 2 questions because we have a little hiccup in the schedule. The next talk actually begins in 5 minutes. So.
Okay.
Yeah, thanks a lot for your talk. I was wondering whether you can also catch relations between time windows. Maybe you say the contact of one contact was on Monday, one contact was on Sunday, and then of course the sequence is important. For instance, if you take your virus example, maybe if A has contact with B and a day later B with C, then of course A can lead to the infection of C.
Yeah.
But if B has first contact with C and then A has contact with B, then C cannot be infected by A.
Yeah, that's right.
And is this something that you can model with your language?
Yeah, so I think this question was regarding like time respecting paths in our case, and this is one point of future work in our system. That's we put them in a temporal pattern matching operator, where you can define in your pattern that you're looking for the chronological order of these things. And in this example here, this was only a grouping on that small period, and we consider, okay, if these periods are like in 1 hour, then we consider all connection in this hour and doesn't, or the chronological order doesn't play a role in that example. Yeah.
So one more question. No, then thanks a lot.
Yeah.